welcome to Introduction to Probability. Just before we start, a reminder that there is a notes jotter available for this video. Just check the description below for a download link and you can work along with me as we go through the video. We're going to begin by taking a look at the probability scale. Now the probability scale has two extremes. It starts with 0 and goes to 1. All probabilities must lie between 0 and 1, and the reason that we use those values is that a value of 0 for probability means that there is no chance of it happening, that it is entirely impossible. A value of 1 is like 100%, it is definitely certain to happen. Now in the middle we get a value of a half, and so that is where we have even chance. It is just as likely to happen as to not happen. Now in between that we have unlikely and likely. Now unlikely does not necessarily hit exactly here at a quarter, it just lies in this area. It is more than impossible but less than even chance. So somewhere around here we find unlikely. Something which is likely is more than an even chance, but it isn't yet certain, and therefore it is somewhere in between the half and 1. So let's see if we can use some of those words in order to answer a few questions about probability. So the first one is you roll an odd number on a fair die. Well, if we are thinking about a fair die, what we are thinking about is a 6-sided dice, and the values that we can get therefore are 1, 2, 3, 4, 5 or 6. So the question is, which of those are odd? Well, 1, 3 and 5 are all odd. Which ones are even? 2, 4 and 6. And you can see we have the same chance of getting an odd number as we do an even, because there are 3 of each. And so because they are equally likely, we have even chance. The next one, you will answer a maths question today. Well, the fact that you are watching a video on finding probability, that is a maths situation, and so you are answering maths questions. You are certain to do that. You will swim to the moon. Well, let's just take one thought about getting from Earth to the moon. Well, there's no water. Therefore, that is absolutely impossible. And finally, you roll a number greater than 2 on a fair 6-sided die. Well, let's have a look at the list that we already had. What would it mean to be greater than 2? Well, that would mean 3, 4, 5 or 6. There are more ways of getting a number that is greater than 2 than there are of getting a number 2 or less, and therefore that is likely. It's not yet certain, but it's greater than even chance. Now what we've just looked at is some of the language of probability, but what we want to move on to is actual numerical values of probability. We had a scale of 0 to 1. We want to try to use numbers wherever we can to actually describe a probability exactly. So probability is given by the number of ways it could happen divided by the total possible outcomes. Now this may seem a little bit strange until I give you some examples. So here we have a spinner, and it asks what is the probability of getting yellow on this spinner. Well, let's have a look at the spinner. How many different ways are there that I could get yellow? Well, there is just 1. But the total possible outcomes are all of the different spaces that it may possibly land on. And so in this spinner there are 6 different spaces. And so the probability of getting yellow would be 1 over 6. It would be 1/6. What is the probability of getting red on this spinner? Well, if we have a look, how many different ways could that happen? Well, there is a red at the top and there's a red at the side, and therefore there are 2 ways of doing it, but it's still out of 6. Now here, this is a fraction which can be simplified, and so if we can simplify, we should. So 2 over 6 is the same as a third. What is the probability of getting blue or pink on this spinner? Well, in this case, how many different ways could that possibly happen? Well, there's 1 blue, 2 blues and a pink. So 2 blues and a pink gives me 3 different ways it could happen. out of 6. 3 out of 6 is a half. And what is the probability of not getting pink on this spinner? So how many different ways could I not get pink? Well, I could get yellow, blue, red, blue, or red. And so there are 5 different ways that I could do it. And it's still out of 6. Now, the important thing here is that if I actually looked for the probability of getting pink, so if I got the pink, it would be 1 out of 6. What can we say about these two probabilities? Well, if we think about adding them, they would add up to a total of 1. And that is because it covers all possibilities. 5 6 is not getting pink, 1 6 is getting pink, and so altogether that is all of the possible outcomes. And so all of our probabilities should add to 1 if they cover all possible outcomes. So now we're going to look at some wordy questions. We've been told that a bag contains 4 red counters, 6 blue counters and 2 white counters. 1 counter is picked at random from the bag. What is the probability of picking a red counter? Give your answer in its simplest form. Well, in this case, what we need to think about is, first of all, the question is about getting a red counter. So how many different ways could I get a red counter? Well, there are 4 of them. So the top of my fraction is going to be 4. But the bottom is the total possible outcomes. And so that comes from all of the different things that I could select. I could have selected 4 red, or 6 blue, or 2 white. And so how many counters were there in total? There were 12. And therefore the probability is 4/12, which, if we simplify, well, we could half it, it would be 2/6. And if we half again, it would be 1/3. The probability of selecting a red counter is 1/3. The probability of it raining tomorrow is 0.6. What is the probability that it does not rain tomorrow? Well, these two events, raining and not raining, they cover all of the possibilities. There is no other possible outcome. And therefore, those two probabilities must add up to 1. Therefore, to find out the probability it will not rain, I will take 1 and subtract 0.6. And 1 take away 0.6, well, that is 0.4. There is a 0.4 chance that it will not rain tomorrow. And finally, we're looking at how some students actually get to school on a morning. And the probability of each mode of transport is shown in the table. So 0.4 is the probability of walking, 0.15 is the probability of taking a car, and x is the probability of taking the bus. Calculate the probability of a student taking the bus. Well, again, these 3 situations cover all possibilities. They're the only 3 ways that the students actually get to school, and therefore all of the probabilities must add to 1. So the first thing I'm actually going to do here is just add together the 2 that I already know. So 0.4 plus 0.15. Add those together, I get 0.55. In order to work out what the value for bus must have been, well, I'm going to subtract 0.55 from 1. And so 10 take away 5 is 5, 9 take away 5 is 4, 0 take away 0 is 0. And so x equals 0.45. And we end with the exam question. It came from the Edexcel paper in June 2017 and it was on Foundation Paper 1. There are only 7 blue pens, 4 green pens and 6 red pens in a box. 1 pen is taken at random from the box. Write down the probability that this pen is blue. So, once again, what we need to be thinking about here is how many ways could I get a blue pen? Well, there are 7 of them, and therefore 7 is going to be the top of my fraction. The bottom, though, needs to be all of the possible outcomes. So there were 7 blue pens, 4 green pens, and 6 red pens. How many pens is that in total? Well, that is 17 pens. and the probability therefore is 7 out of 17. We should be checking if we can simplify, but both 7 and 17 are prime numbers, so 7 over 17 is the final answer.